Oh well, here we go. Talking about inverses today. A lot of people confuse inverses with opposite. These aren't the same thing. Opposites are kind of like changing directions. One moment you're facing one way, positive, and negative you're turning the other way. Think of inverses as more turning inside out.
He was just an ordinary kid, until that fateful day when he accidentally swung over the bar and learned he had incredible powers beyond those of any superhero.
Where are my pants?
He had become Inside Out Boy.
Or, better yet, think of inverses like undoing something. However you understand inverses, they are essential for solving problems forward and backwards. And you've actually been using them forever. Here's a function machine. What's it do? It takes a number, we'll call it x, and adds 3 to it. Let's use 5 as our first input. Of course, the output is 8. Now, the inverse shows up when we take the output and use it as an input. What function would we use to get it to output our original number, 5? It'd have to be x minus 3. Because you see, addition and subtraction are inverses of each other, as are multiplying and dividing. Another set of operations that are inverses of each other are squaring and square rooting. These two will also undo each other. Knowing inverse operations as far as what cancels out what is handy when you're trying to find inverses in the world of functions. It's pretty easy to see in our earlier example that when the function f of x is x plus 3, the function that's going to undo it, we write it like this, f to the negative 1. This inverse function is x minus 3. But what about the inverse of a more involved function? How do we go about finding that? I'll show you in a little bit. First, let's look at what the inverse functions look like in the different ways we have to show a function, the different representations. We'll look at tables first. Here we have x plus 3 and its inverse x minus 3. In our function f, using these values for x, we get these answers for y. Now let's take the y's, the answers we just got, and use them as x values in the inverse function. You see that the answers we get here match up with the x's in the original function. Look at what basically happened. The x's and y's switched places. Here's a function that's just 5 pairs of numbers written in a table. To show the inverse, all I'd have to do is switch the input and output columns, like this. What about inverses on a graph? What do two inverse functions look like on a graph? Here's the x plus 3 and the x minus 3 example we've been using. These two lines are a reflection of each other. The line of reflection, right here. This dotted line is the function y equals x. In other words, this is the line that is graphed whenever your x and y are the same number. Let's do another graph, something crazier. To find the inverse, remember that we're going to reflect over the y equals x line, which is right here. The inverse of our original blue line is going to look something like this. Look at where the original and the inverse intersect. It's right on the line of reflection. You'll also see that from the line of reflection, our two graphs are the same distance on either side of it. We've now looked at inverses when it comes to a table and a graph. For the annoying grand finale, we'll do the inverse of a function rule. Pure math time, baby. Let's do f of x is 3x minus 5. Step 1. Replace the function notation with y. Step 2. Switch your x's and your y's. And finally, solve for y. Remember to change it back to function notation at the very end. So, recap time. Inverses are like taking a function and undoing it. If the original function is f of x, we label the inverse with an f to the negative 1. With a table, we just switch the x and y of each pair. With a graph, we reflect over the line y equals x. And with a function rule, we follow 4 steps. 1. Rewrite your function in y equals form. 2. Switch the x's and the y's. 3. Solve for y. And 4. Rewrite it in function notation. I hope this helps you get your feet wet with inverses. Now, go practice and master it. We'll be using inverses to solve problems all year long. Until next time, stay awesome.